We're going to look at a few things from 3.1.2, just kind of emphasizing some important points. So I'm going to start with E on the first page. I know I talked about this with most of you, but Monica dilated ABC to get a different triangle. She knows that A double prime B double prime is 20 units long. How many times larger is ABC than A double prime B double prime C double prime? So I have to look back up here. So I need to be able to figure out that A double prime B double prime is going to correspond with AB. So just like on our homework, we had to find the lengths of that. If I am finding that length right there, I can just count. So AC is going to be 3. I know that this is 4. I cannot just count jumps. I can't count diagonals, so I essentially have a right triangle here. So I am able to do Pythagorean theorem to be able to figure out what AB that is going to be. So 3 squared is 9. 4 squared is 16, C squared, and then 25 equals C squared. And I know to go from C squared to just C, we're going to take the square root, so that is going to be 5. So if I go back down to E, it said A double prime, B double prime is 20. So I went from what we found AB to be 5. So I went from 5 to 20. So in that case, I can do 20 divided by 5. And my scale factor, how many times larger, would be 4 times larger for the double prime. So then it also asks how long is B double prime, C double prime. So I could go back up and figure out that BC is 4. So I can take and multiply that by 4. So 4 times 4 would be 16 because it's 4 times bigger. A couple other things really quickly. We figured out that something with a scale factor of 1 should just be the same exact thing, and overall you guys did a pretty good job with this. So we're going to quickly take a look at the last page. So in 315A, it says that Casey wants to learn more about her enlarged C's. Return to your work from problem 313. Since the zoom factor multiplies each part of the original shape, then the ratio of the widths must be equal to the ratio of the lengths. So Casey decided to show these ratios. So we want to verify that these are the same. It's pretty easy to do this. 24 divided by 8 is 3. 18 divided by 6 is 3. So those are going to be the same exact ratios. So then if I look at this one, when looking at Casey's work, her brother wrote the equation 8 over 6 and 24 over 18. So are these going to be equal? And then it says to draw or add arrows to show. So I go from 8 over 6. So as long as I take that same pattern for the other one, then we're okay. So I have 24 over 18. And if I simplify those fractions, 8 over 6 simplifies to 4/3, and then 24 over 18, if I take a 6 out of those, also simplifies to 4/3. So that's the same thing. So then if I look at C, it says she has decided to create an enlarged C for the door of her bedroom. To fit, it needs to be 20 units tall. If X is the width of C, write and solve an equation. Find how wide the C on Casey's door must be. Be ready to share. So I could take that same method using those arrows right above. I could say 8 over 6 is equal to, and then if I say 8 over 6, I need to say 20 over X. So I can have our proportions that look like that. So if I have proportions equaling each other, I can do 6 times 20 to give me 120 is equal to 8x. Divide by 8, divide by 8, x is equal to 15 units. So our answer there would have to be 15 units. Again, that's not the only proportion that I can set up. If I stay consistent on how I set up the first proportion with the second one, we have many, many different options. I could say 6 over 8. So I could go in reverse order, is the same thing as x over 20. So if I cross multiply, I still have 20 times 6, so 120. I still have 8 times x, and I would still divide by 8, and x is equal to 15. So we could do that. As long as we stay consistent, it does not matter. If I wanted to, I could technically say 8 over 20. So if I say 8 over 20, then I would need to make sure I have 6 over x. So 8 over 26 over x, I still have that 20 times 6 and 8 times x to give me the same thing. I really could go the other way around as well. I could say, if I go big shape to small shape, I could say x over 6 is equal to 20 over 8, and I get that. So again, similarity, as long as I can stay consistent on how I set up my proportions, I've got many, many different options. We're not stuck to just one way of finding them. So hopefully this was helpful, and we'll see you all Thursday.